Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 41 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have two different quadratic functions. We don't even have a visual representation here, so we're going to have to make one up on our own. They were graphed on the same coordinate grid. The vertex of the graph Q is 18 units below the vertex of graph W. And then take a look at my options here. So all of my W's are going to be just your basic parent function. So if we were to graph this right here, this is the most standard quadratic function you can get. It's just Wx equals x squared. So I'm going to just graph it right here, and I know that it's going to go through the origin. It's going to be kind of spaced like that. It's going to be facing up. So this is what we would call our parent function. One of the things we learn in Algebra 1 is what happens when you start modifying that parent function. So you take that same thing and then you add a modifier in front of the x squared, or you add an addend. And so what is it that moves the vertex? So the two things that they give us options here for, right? You see this right here and this right here. So we will call this, it's a q of x. So q of x equals a x squared. So what they've done is they've added a multiplier coefficient in front of that x squared, and then that a is doing something to that x squared to kind of shift things. So what do we know about that? Well, if a is less than 0, then it is actually reflected down. So it's actually inverted across the x-axis, and it actually opens up down. So this one right here would be a downward opening graph. But that doesn't say anything about the vertex here. If the a happens to be between 0 and 1, it's going to be wider. Still facing up, it's going to be wider. And then if the a is greater than 1, it's going to be narrower. So all of this putting this a in front of this x squared, or the 18 or negative 18, is going to change the direction and how wide or narrow it is. It's not going to do anything about shifting it up and down. So it's not going to be a, it's not going to be c. Now look what we have here. We have a plus 18, we have a minus 18. So we can view it this way. So q of x equals this x squared plus c. So it's this c. What does that c do? Well, I've got a positive 18 here, I've got a negative 18 here. That c is actually going to shift the vertex. It's going to move it up or down. So if the c is greater than 0, the vertex goes up. It just moves up 18 points. If the c is less than 0, it is going to move down, so it's going to move down 18 points. So if it says the vertex of graph Q is 18 units below, then I'm thinking it's going to be that D. But when in doubt, let's open up our graphing calculator and just double check our work. So on my TA84 here, I'm going to go to my y equals. And let's just go ahead and put the parent function in there. So that's going to be y, or in this case wx, equals that x squared. Let's just see what that looks like. And it's going to be your basic function. It's zoomed in out a little bit. So let's zoom that in just a hair, and we'll see what happens. Then we're going to go over here, and we are going to say, x squared minus 18. What happens if we shift that down? And wow, look how much farther down it goes. I will have to zoom back out. So it's the same graph, it just shifts down 18 points. So what we did here, if this is the function w of x, then your same function is going to be down here. This is going to be your q of x. Same shape, because we're not modifying it with an a in any way. We're literally just moving it down 18 points. So our answer here is going to be D.